Hello everyone, this is Zamani. I'm a researcher at Microsoft and I'm going to present work generating clarifying questions for information retrieval and in particular web search. Um, and this is the work that I've done in collaboration with Sue Dumais, Nick Craswell, Paul Bennett, and Gord Lueck, all from Microsoft. So as all we know, search queries are often short and they may not reflect the actual user information need or user intent. So we deal with a lot of ambiguous queries, a lot of faceted queries. And to deal with this problem, search result diversification has been proven to be a successful approach in the typical traditional web search and other search scenarios as well. However, when it comes to the search with devices that have limited bandwidth interfaces, such as speech-only interface, search result diversification is not practical anymore. And we can solve this issue by asking a clarifying question from users. And this is not only related to these search scenarios, these limited bandwidth interfaces. We are going to show that these can be also helpful in web search with the traditional TimBlueLink interface. For example, in a web search, for some queries that can have multiple aspects, we can ask a clarifying question and show a set of options to the user. In this example, we have the query blue screen. We can ask what version of Windows are you looking for? And the user can click on the version that they are interested in, they're using. For the query 20th anniversary gift, you can ask who are you shopping for. For the query NSFL, which can refer to different entities or different concepts, we can try to disambiguate this query, ask which NSFL do you mean? And another example for query wedding dresses, we can ask, do you have any theme in mind? Summer, modern, fall, beach, retro. These are setup options that the users can click on. In this paper, we are going to address 4 major research questions. The first one is, what benefits and needs do people report for clarifying questions in the traditional TimBlueLink web search? So in other words, what is the usefulness of these clarification pane in web search? The second question would be, what type of clarifying question do we observe from people's behavior? Or what is the taxonomy of clarification types for asking a clarifying question? The third question would be, how can we generate clarifying question? And the next one, which is tightly coupled with the third, is how we can select a diverse and relevant set of candidate answers for clarifying questions. In this presentation, I'm going to talk about all of these research questions with the same order. So let's start with the first research question. What benefits and needs do people report for clarifying question? In other words, how useful is clarifying question and how important it is to use this in web search. We started with a small user study. We had 5 participants, 2 males, 3 females from different educational backgrounds, and we defined 4 diverse information seeking scenarios, from removing favorites from the web browser history to getting information about a high school, getting information about a medicine, or learning more about Irish castles. So we asked them to use Bing, that has this clarification pane feature, and complete this for information seeking scenarios. After that, we interviewed these 5 participants. All the participants showed high enthusiasm for this clarification pane. And they mentioned that it's a convenient and easy feature and it saves some time and steps. These are a couple of quotes from the users. They mentioned that it sometimes cues the user to things they may not have considered. So this is interesting that these clarification panes and actually the options that we provided help them to understand the space of the search. If they don't know what is all the informations that are related to this query, they can search about this, learn more about this by looking at the clarifying question and the candidate answers. They also mentioned that this helped them to find more relevant results. We also asked them to give us some feedback about non-relevant or low-quality clarifications. So if the system generates a bad clarifying question, what they think. An interesting observation was that they did not think that the search experience was degraded. For example, this is the quote from one of the participants. It's like when I look at iPhones on eBay, and eBay says, since you looked at iPhones, you may be interested in these hair curlers. And I'm like, well, that's weird, but whatever. So it's interesting to see this, and it's actually because we showed this clarification pane on top of the result list, so they can simply ignore bad clarifying question and go through the result list directly. On the other hand, they believe that the quality of the second result page, when they click on one of the options, on the answers to the clarifying question, is actually very important. So this user study encouraged us, gave us good feedback, positive feedback. So we extended our user study. We did another one with 24 participants. So we asked them to use Bing for 2 weeks for their daily needs, and then we interviewed them to talk about their experience with this feature, clarifying question feature. In summary, the participants mentioned that there are 2 sets of benefits. One functional benefits and the other one is emotional benefits. The functional benefit, which is actually the main motivation behind generating clarifying question, asking a web search, is questions help guide users in the right direction and to the right conclusion. On the other hand, emotional benefit is also very interesting. The user believed that the search engine is more intelligent than before, and it brings to users a sense of confidence that the search engine understands what the user wants. We also asked the participants to rate the features, every feature in the SERP, and the clarification pane as among the most favorite features with a rating of 9.13 out of 10. In the online experiment with 2.5 million users, we wanted to study the importance of clarifying question. So we ran an A/B test, and in this experiment, we only changed the clarifying question. So for the same query, we will see the same set of options, but in one case, we have a clarifying question, what version of Windows are you looking for? But in the other one, we have a generic text for all the queries, like select one to refine your search. And the goal is to identify what is the importance of asking this clarifying question in web search. And it was interesting to observe 48% more user engagements. And user engagement is measured based on click-through rate. So this gives us another signal to show the importance of clarification in web search, even when we are dealing with this traditional tabulating interface. So in summary, in conversational information seeking, asking clarifying question is convenient, and we would like to go in that direction. Our user study also showed that clarification pane is useful, and it brings both functional and emotional benefits. Our online experiments show that 48% relative CTR improvements can be achieved by asking a clarifying question compared to like a typical query suggestion setting. The next part of the presentation, I'm going to talk about taxonomy of search clarification. In other words, I'm going to answer the research question that what types of clarification questions do we observe from people's behavior? To do this, we went through a large scale query log. We look at the query reformulation data. Particularly, we look at specializations when the following query contained the original query in the same session. And we try to identify different dimensions of clarification. So our taxonomy consists of 4 major categories. The first one is disambiguation. Some queries are ambiguous, and they may refer to multiple entities or multiple concepts. So a clarifying question can help disambiguate these queries. The second category is about preference. The preference can be related to personal information, spatial information, temporal information, or the purpose of the user for consuming that information. The third category is related to topic. For example, the query can be too broad and it can cover multiple subtopics. So we can ask a clarifying question to identify what subtopic the user has in mind. Or the query can be related to a recent event or news, so we can ask a clarifying question to identify what the user wants. The last one is about comparison. For example, assume that the user wants to purchase a gaming console, and it is difficult to identify what is the right gaming console for some people, but when they search for example, Xbox, we can ask, do you want to see Xbox versus PlayStation, to see the difference and compare these two products, and this would help them to identify and address their information need. The next part of the presentation, I'm going to talk about how we can generate a clarifying question and how we can select a diverse set of relevant candidate answers for those clarifying questions. We propose 3 methods for generating clarifying question. 1 very simple template-based method, and 2 machine learning method based on text generation. But before jumping to the models, let's see one example to better understand how these models should be constructed. Assume that you have a query X17:16 and you want to ask a clarifying question for this query. What would you ask? Well, many of us probably don't know what this query means or what are different aspects of this query, what needs clarification for this query. But if I tell you that this is an act in Bible and it is different in different translations of Bible, I think it's then become much easier to ask a clarifying question. For example, you can ask, what Bible translation are you looking for? The point that I wanted to make with this example is that to generate a clarifying question, we need to identify different aspects of the query. In this example, different aspects of this is different translations of Bible. Therefore, we have a query aspect generation component in all of our models. It starts with collecting a larger scale query logs from a search engine. Then we extract this query formulation data from these query logs, the query formulation data from the same session, and we focus on specialization type. In the specialization, the following query, for example, Q prime, contain the original query Q with some additional words. And the assumption here is that when we observe this specialization reformulations, we can get more information about the actual intent of the original query. We will see in the next slide that is actually very helpful, but this would work when we are dealing with head queries. For tail queries, this data would be very sparse. Therefore, we need to do some predictions for unseen reformulations. We use typical collaborative filtering techniques, for example, neural collaborative filtering, to predict these unseen reformulations, especially for tail queries. The last step is to normalize these weights to compute the probability of every reformulation. This is an example for the query shoes. As you can see, in the reformulations data, we can identify different aspects of the query. For example, different type of the shoes in red, different brands of the shoes in green, and the person who's going to use these shoes in blue. So we can identify different pivots that we can ask a clarifying question. And actually, a big question here is what pivot to use to generate the clarifying question. Should we ask a general clarifying question, or should we ask a specific clarifying question? So the first model that we have is a template-based approach. So we defined a set of templates for asking clarifying question. For example, what do you want to know about query? Or who are you shopping for? Who are you looking for? And then we try to fill out the slots in these templates. As you can see, many of these slots require entity type information. So we used an OpenIE toolkit to extract these entity type information from a larger scale text corpora. The data we used is the query formulation data. We obtained 1.6 billion unique query formulation pairs from Bing. It covers over 500 million unique queries. For the entity type information, we ran reverb on over 35 petabytes of Bing snippets, and we only extract the is-a relations. And for evaluation, we randomly sampled 250 queries from the query log. And these queries are diverse. So we randomly select from tail queries and head queries. We also have samples from queries with many reformulations, queries with few reformulations. And we use human annotations to evaluate the models. For example, we evaluated this RTC model, the template-based model, based on the human annotations. We asked the annotators to provide a label between 0 and 2, so bad, fair, and good labels. And then we have a linear score, which is the linear combination of these weights, 0, 1, 2 weights for these labels. And we have an exponential score, which is exponential weights for these labels, similar to the NDCG gain function. So this is the results about the quality of the questions. And we also have results for the specificity of these questions. How specific are the questions generated by this? And as we can see, there are only a few specific questions by this model. So in summary, RTC is a simple yet effective method. However, it fails to provide specific questions, especially when the entity type for the query or its aspects is unknown. So we need to do some generalization. In order to do that, we a machine learning model called QLM, or Question Likelihood Maximization. This model is similar to the sequence-to-sequence model. We have a query encoder on the left-hand side, takes the query and the entity type of the query if is available. We also have single aspect encoders. It takes the query and the aspects of the queries from the query reformulation data and the entity type of the aspects. And then we have a query aspects encoder that aggregates all of these single aspect encoders. And at the end, we have a decoder that generates a clarifying question. You can use your own favorite network architecture for these components. In this paper, we use ByLSTM for the encoding part and LSTM model for decoding. The training of these models is based on maximum likelihood. So the objective is to maximizing the likelihood of generating the clarifying questions observed in the training set. In this equation, V is the encoder's output. Because we don't have training data for training this model, we use weak supervision. So we use the RTC model, the rule-based, template-based model, to generate a set of questions, and it's been used as the weak labeler in our data. So we generate a clarifying question for 100,000 queries, which was sampled from query logs, and then use that data for training this model. We ask the annotators to label the generated questions, and we can see that the quality of the questions improved, and also this model learned to ask more specific questions. And the reason is that this QLM model tries to generalize and identify the entity type information of the aspects and the queries based on the query formulation data. Therefore, QLM can generate more specific questions with higher quality compared to RTC. However, the objective of this model is maximizing the likelihood of questions. While we would like to have a model that maximizes a clarification objective, we want to have a question that has a high probability of clarifying the information need of the user. Therefore, we propose our third and final model, query clarification maximization. This model is based on reinforcement learning, and it tries to maximize a clarification utility function as a reward function. So given a query, we first generate the query aspects, given the approach that I presented earlier from the query reformulation data. Then we generate the question, and the architecture for the question generation model is the same as the one I presented earlier, with the similar to the sequence-to-sequence model. And then we generate some candidate answers, and at the end we estimate the clarification probability of this and use that value as a reward function. So the training is based on mixer. Mixer is training with maximum likelihood, and then keep training it with the reinforced algorithm. And the objective for the reinforced algorithm is the one presented in the slides, and the R function is the reward function, which is the clarification utility. The clarification utility function is computed as the probability of clarification is equal to 1 given the query clarifying question and the candidate answer set. And this can be computed by having a summation over all possible intents, which are generally unknown, but we can estimate this using the query formulation data by looking at the aspects generated by the query aspect generation model. For the details of computing this probability, please refer to the paper. So in the candidate answer generation, we are looking for a candidate answer set A that maximizes this clarification utility function or this probability. But this is an NP-hard problem. However, the good news is that it's a monotone and submodular function. So we can use this theorem from Fisher et al. That has a nice approximation, reasonable approximation for optimizing these functions. So the solution is to just have a greedy algorithm that generates candidate answers one by one. So again, we use the human annotators to label our data, and then we observe that this model leads to higher quality questions, clarifying questions, and which are statistically significant, also more specific clarifying questions. And the intuition is that this model tries to maximize the likelihood of clarification. We also evaluate the answer set. We compare this against a set of baselines, the maximum likelihood estimation and maximum marginal relevance, which is a diversification technique for diversifying the answer set. We observe that this formulation that we have for maximizing the clarification probability has a better quality of answer set and also the next result page quality. There are more experiments, more analysis, more results in the paper if you would like to take a look. Here is a few examples for the clarifying questions and the candidate answers generated by our final model. For example, for the query Retrieval, we ask, what do you want to know about this medication? And the options are dosage, coupons, side effects, cost, and information. And here are a few more examples. So in summary, we introduce the task of generating clarifying question for web search. And we performed a set of user studies and online experiments to motivate the task. We presented a taxonomy of search clarification, which was derived from query formulation data. And we proposed 3 models for generating clarifying questions, 1 template-based approach, and 2 machine learning models. And at the end, we proposed a model for selecting candidate answers. This work has a set of limitations, and there are a set of future directions that we would like to take. For example, it would be nice to go beyond query logs and consume clicked data information and set of top retrieved documents. Another thing would be considering answer coherency and computing the clarification utility function. We would like to also extend our work to multi-turn conversation and also generate clarifying questions based on personalized information and session information. At the end, it would be interesting to see how we can utilize user feedback, the implicit feedback of users, to improve the approaches for generating clarifying questions. Thank you for listening. Please feel free to send email with your questions, and I will be available to answer your questions via Zoom.